Welcome to today's Explainer. We are jumping right into something completely wild today. We're going to look at how a shift in ocean water, literally thousands of miles away, can completely dictate the weather patterns, the agricultural wealth, and honestly, the entire economy of the Indian subcontinent. It's this massive, complex chain reaction, and it all boils down to a phenomenon you've probably heard of, El Niño. So let's trace how these invisible ripples travel all the way across the globe.
Section 1, an early but weak monsoon. Let's set the stage by looking at a pretty fascinating paradox that's unfolding right now.
So we're currently seeing a really stark contrast. On one hand, the monsoon is actually arriving early. The India Meteorological Department, the IMD, pegged the onset in Kerala for May 26th. That is a full 6 days ahead of the usual June 1st arrival. Now, on paper, that sounds like great news, right? Early rain. But at the exact same time, the IMD is projecting a below-normal rainfall season, sitting at just 92% of the long-period average.
Which brings us to a huge question. If the rain is arriving early, why in the world are meteorologists and farmers alike bracing for a dry season? Well, as the experts point out, an early arrival offers zero guarantee of an actually strong monsoon season. And the answer to this whole meteorological mystery? It doesn't lie over India at all. It lies far, far away in the waters of the Pacific Ocean.
Section 2. Decoding the El Niño phenomenon. To understand this, we really need to look at the primary mechanism driving this entire paradox.
Before we go any further, let's just ground ourselves in this science for a second. The overarching system we're talking about here is called INSO. That's the El Niño Southern Oscillation. Basically, it's a periodic climate cycle that swings back and forth between two phases. You have El Niño, which is the warming phase, and La Niña, the cooling phase. And while this whole dance happens in the central and eastern Pacific Ocean, its reach is literally global.
Normally, you've got these strong trade winds blowing warm water west toward Asia. But during El Niño, those winds get weak. They just kind of give up, and all that warm surface water sloshes right back east towards South America. Actually, fun fact, it was 17th century Peruvian fishermen who first noticed this unusually warm water rolling in around December. So they named it El Niño de Navidad, or the Christmas child. Pretty poetic, right? But today, we're focusing entirely on the trouble this child causes.
This eastward shift of warm water messes up what's known as the Walker circulation. Simply put, that's the east-west atmospheric circulation right over the equator. When El Niño alters this massive pressure system, it directly suppresses the vital, moisture-laden winds that would normally blow toward the Indian subcontinent. So the fuel for India's rain is effectively cut off right at the source.
Section 3. The summer monsoon deficit. Now that we've got the ocean mechanics down, let's bring our focus back home to India and trace those atmospheric ripples into the summer months.
Let's look at that number from the IMD again, 92%. The long period average, or LPA, is basically a historic benchmark calculated over decades. According to the IMD, anything below 90% is officially classified as deficient and is heavily associated with drought conditions. So at an expected 92%, India is skating uncomfortably close to severe water scarcity. And unfortunately, this likely marks the end of 2 consecutive years of above normal rainfall.
If you really want to know what El Niño is capable of, history paints a very clear, very dry picture. During the devastating 2015-2016 El Niño event, India received only 86% of its normal rainfall. And this wasn't just a minor inconvenience. It caused severe localized deficits. For instance, regions like Marathwada in Maharashtra saw nearly a 40% rainfall deficit. That leads to absolute disaster for crops and massive water shortages.
And hey, we don't even have to look back a decade. Just recently, during the 2023 El Niño, India experienced a staggering 36% rainfall deficit in the month of August alone. Keep in mind, India receives nearly 70% of its annual rainfall during the June to September monsoon season. So a bone-dry August? That is absolutely catastrophic for the entire year's water supply.
Section 4. Winter disruptions and dense fog. Now, if you think El Niño only dries up the summer, think again. Let's pivot to a completely different season and look at how it totally disrupts Indian winters. Remember that bizarre winter of 2023 to 2024? The one that blanketed North India in severe cold days and zero visibility fog? Well, the IMD attributed that mess to a complex trio of factors. First, a total lack of active western disturbances. Those are the weather systems that normally bring winter rain and snow. Second, prevailing El Niño conditions.
And third, incredibly strong jet stream winds blowing it up to 320 kilometers per hour. El Niño is a key accomplice in all of this atmospheric chaos. The result of those missing western disturbances is just stark. Take a look at the western Himalayan region. In December of that winter, there was an 80% departure from normal precipitation. Think about that. Almost no rain and almost no snow, completely drying out regions that normally rely heavily on a thick winter snowpack for their year-round water supply.
Section 5. The toll on agriculture. Finally, let's follow this ripple effect as it actually hits the ground. We've talked about ocean currents, pressure, and rain deficits. Now, let's translate all of this into tangible human and economic impacts.
This is a jaw-dropping statistic from the Central Research Institute for Dryland Agriculture. By looking at historical data, researchers found that average crop production dropped by an astounding 42.7% during El Niño years. That is massive. Overall productivity itself dropped by over 36%, because at the end of the day, when the rains fail, the fields simply cannot produce.
The pain is felt most acutely during the Kharif season. These are the crops sown right at the beginning of the monsoon, and they're incredibly reliant on consistent moisture. During these El Niño-induced dry spells, short-duration and moisture-dependent crops get absolutely devastated. The sources point out that maize production plummeted by up to 23% in certain districts, while rice and groundnut yields suffered widespread reductions right at their most critical growth stages.
So how does a lack of rain turn into a full-blown nationwide economic shock? Well, it's a massive domino effect. Roughly 60% of India's farmers depend entirely on the monsoon. When crops fail, agricultural stress spikes, which leads to an immediate drop in rural income. That weakens consumption demand across the board. Furthermore, low reservoirs mean less groundwater recharge for drinking and reduced hydropower generation, which strains the energy grids. And the final domino, reduced crop output pushes up food prices. That causes food inflation to spike for every single person, whether you live out on a farm or in a high-rise apartment in the city.
So as we wrap up this explainer, I really want to leave you with this thought. We so often view our local weather and our local grocery stores in complete isolation. But when weakened winds in the Pacific Ocean can lead to a 40% drop in crop yields and spike inflation all across India, it forces us to ask, how resilient is the food on your plate when a single ocean current shifts? It's a stark reminder of the extreme fragility and the incredible interconnectedness of our global climate. Thank you so much for exploring this with me, and I hope this helps you see the broader picture the next time you hear a weather forecast.